Appendix of Pioneer Work in the Alps of New Zealand by Paul Harper. This LibriVox recording is in the public domain. Recording by Gail Timmerman Vaughan. Appendix. Note 1. Meteorological conditions of the Southern Alps. Owing probably to the low altitude of the Fox and Franz Josef glaciers, together with their bulk and rapid motion, it has been assumed that a great difference exists between the east and west sides of the Southern Alps in the matter of glaciation. Various theories have been put forward, and the meteorological conditions have been called in to account for this peculiarity. The average rainfall at Hokitika is 126 inches a year, and at Christchurch only 25 inches. There is apparently a great difference between the insolation and radiation, and also the degree of moisture, on the one side and the other side of the island, on the seaboard. I do not pretend to be an authority on, or even to have attempted to study, meteorology, and do not put forward my opinions on the subject from that point of view. At the same time, I should like to point out a few facts regarding the rainfall and the glaciation of the Southern Alps, concerning both of which I am in as good a position as anyone to speak, for at present I have the honour to be the only person intimately acquainted with both sides of the High Alps. In the first place, until recorded observations prove that I am wrong, I believe that the rainfall in alpine districts near the dividing range is very little greater on the western slopes than on the eastern. My experience has been that the northwest wind, which brings the heaviest rain, is very nearly as wet for 4 or possibly 5 miles on the east as on the west. This region includes the greater proportion of the eastern glaciers, and it is within this area that the heaviest snowfall is found. Consequently, if I am correct in my premises, it follows that there is no reason why there should be a heavier snowfall or greater glaciation on the one side than on the other. Now comes the second point, namely, is there more snow and ice on the west coast than on the east? I submit that there is not. True, there are a greater number of separate glaciers, but they do not compare with the eastern glaciers in size. They are due not to a greater snowfall, but to a larger number of valleys. On the east coast we find the great Tasman Glacier flowing for nearly 12 miles at the foot of the divide and receiving many tributaries. Supposing that, instead of flowing in this direction, there were spurs and divergent ranges, jutting out at right angles to the main range, from Elie de Beaumont to Mount Dampier, what would be the result? Assume for the sake of argument that long spurs ran off at right angles from the former peak to La Beche, Conway, Haast and Dampier. I contend that if the valleys enclosed by these spurs narrowed and descended rapidly, we should have a second Franz Josef in the first named valley. The Rudolph would equal the Balfour, if not exceed it. The Haast Valley would contain a glacier little less in area than the Franz Josef Glacier, and the Hochstetter ice would exceed the La Perouse Glacier. Examine other districts. The ice at the head of the Godley River far exceeds that on the western side. At the head of the Rakaia, the glaciers equal if not exceed those in the Wanganui River. On the Multerbrunn and Hooker ranges, the chief glaciers lie on the eastern, not the western slopes. It may therefore be said that, even allowing the excess of rainfall on the western side of the Southern Alps to be as great as has been assumed by those who have written on the subject, the difference in the matter of glaciation between the eastern and western sides of the dividing range is not great, and the preponderance of snow and ice does not lie on the west coast. I have stated above that I believe the rainfall for 5 miles on each side of the dividing chain is almost as great on the east as on the west. But beyond this limit we find a great excess on the latter side, probably 4 1/2 times as great. Consequently, those glaciers which extend beyond that limit on the east reach the dry district, and those on the west are still within the wet region. Therefore, even if the glaciers on the former slopes descended in steep, rock-bound valleys, their descent would not be quite so low or so rapid as those on the latter side, because they would not have the assistance which a very warm and frequent rainfall on their trunks must give. But so far from the former descending in steep narrow valleys, they flow down over comparatively easy slopes, and yet reach a low altitude. To account therefore for the extraordinarily low position of the only 2 glaciers which descend to very low altitudes on the west coast, we need not turn to meteorological conditions for a solution of the difficulty, but only need to examine the formation of the country. For even allowing everything, steep valleys and climate, to aid them to reach a low altitude, we find that, with the exception of the Fox and Franz Josef glaciers, the ice fields of the west coast do not reach such a low general altitude as those on the east. And the reason that these two are so very exceptional is that they have such large néves in proportion to their trunks, combined with the narrow and steep valleys. I have not intended to imply that meteorological conditions do not affect the glaciation of the Southern Alps, but merely wish to point out (a) that within the area of glaciation the difference between the meteorological conditions is not nearly so great as supposed, (b) that the glaciation of the west coast is not greater than that of the east, (c) that the altitude of the glaciers on the east is as a whole as low as, if not lower, than on the west, (d) that it is not necessary to turn to meteorological conditions to account for the difference in glaciation, if any, for that can be accounted for entirely by the conformation of the country. Note 2. Altitudes. In semi-official guidebooks to New Zealand, there are so many reckless statements with regard to the heights of the various peaks of the Southern Alps that it would be perhaps useful to give a list of the chief mountains. On page 123 of Brett's Handy Guide, we find Mount Aspiring given as, quote, the highest after Aorangi, Mount Cook, end quote, whereas it comes 20th on the list. In another place, the Hochstetter Dome is put down at 11,500 feet, and so on. Persons who take an interest in alpine matters and make annual excursions into the glacier districts ought to be free from such mistakes, but some are just as reckless. To give only 2 examples, I have seen an account of the ascent of Mount Earnslaw, in which it is called, quote, one of New Zealand's 3 great peaks, end quote. Its place on the list is 35th. In a description of an attempt to ascend Mount de la Beche, the narrator was within 1,000 feet of the summit and could see the upper part of the Tasman Glaciers 7,000 feet below him. This peak is only 9,815 feet above sea level, and the upper portion of the Tasman Glacier is at this point upwards of 5,000 feet in height above the sea. A mistake, therefore, of over 3,000 feet was here made. These errors are often made by persons who should know at least the approximate heights. The omissions of units, tens, and hundreds would not matter, but there is little reason to quote such exceedingly round figures when naming the thousands. I could give many other instances. To avoid, if possible, the repetition of such mistakes in the future, the following list of the peaks over 9,000 feet is given, with a few additional points of interest. Most of the figures are exact, and the rest are subject to very trifling alteration when new values are worked out from recent completed observations. I have confined myself to the central district, only given 1 or 2 peaks outside. These are marked asterisk. Mount Cook 1, 12,349 feet. Mount Cook 2, 12,173 feet. Mount Cook 3, 11,844 feet. Tasman, 11,475 feet. Dampier, Hector, 11,323 feet. Lendenfelt, 10,551 feet. Silberhorn, 10,500 feet. Malta-Brunn, 10,421 feet. Hicks, David's Dome, 10,410 feet. Sefton, 10,359 feet. Elie de Beaumont, 10,200 feet. Hedinger, 10,107 feet. Stokes, La Perouse, 10,101 feet. The Horn, 10,063 feet. The Minarets, 10,058 feet. Stokes Lower Peak, 10,034 feet. The Minarets Lower Peak, 10,022 feet. Glacier Peak, 10,017 feet. Woolsack Peak, 9,968 feet. Asterisk Aspiring, 9,960 feet. Hackle Peak, 9,949 feet. Hamilton, 9,915 feet. Haast, 9,835 feet. De la Beche, 9,815 feet. Cook, 4th Peak, 9,716 feet. Darwin, 9,715 feet. Peak near Darwin, 9,607 feet. Conway's Peak, 9,511 feet. Green, 9,325 feet. Hutton, 9,297 feet. Hochstetter Dome, 9,258 feet. Lower Peak, 9,179 feet. Asterisk, Arrowsmith, 9,171 feet. Spencer, 9,167 feet. Asterisk, Earnslaw, 9,165 feet. Peak near Darwin, 9,144 feet. Footstool, 9,079 feet. Kronprinz Rudolf Peak, 9,039 feet. Dwarf, 9,025 feet. Graham's Saddle, 8,739 feet. Minaret's Saddle, 9,620 feet. Lindenveld Saddle, 7,991 feet. Harper's Saddle, 8,580 feet. Baker's Saddle, 6,300 feet. Ball Pass, 7,426 feet. Ball Hut, approximately 3,700 feet. De la Beche Bivouac, 4,782 feet. Green's Bivouac, approximately 6,780 feet. Terminal Face Murchison, 3,452 feet. Terminal Face Tasman, 2,354 feet. Terminal Face Hooker, 2,852 feet. Terminal Face Muller, 2,516 feet. Terminal Face Fox, Aneroid, 670 feet. Terminal Face Franz Joseph, 692 feet. Terminal Face Victoria, Aneroid, 3,685 feet. Terminal Face Balfour, 2,300 feet. Terminal Face Douglas, 3,663 feet. Terminal Face Horace Walker, 3,511 feet. Terminal Face McCarrow, 4,096 feet. Terminal Face Fetz, 2,950 feet. Karangarua Pass, 5,641 feet. Douglas Pass, 6,115 feet. In addition to the above peaks, there are one or two more on the main chain outside this district: Tapuanuku in the Kaikoura Ranges, and Ruapehu, an extinct volcano in the North Island, above 9,000 feet, besides hundreds of fine peaks of over 8,000 feet in the Southern Alps. Note 3. Black Swans. These birds are natives of the Australian continent, and were introduced many years ago into New Zealand by private individuals. They have since then increased enormously, and are to be found in thousands on our lakes and lagoons. I'm not sure whether they were brought over to the west coast or found their way unaided, but it was not until the early 70s that they first became established on this side of the South Island. 3 or 4 pairs settled themselves on the large lagoon at Okarito, and, unaccustomed to the heavy and frequent floods which occur in the spring, they built their nests too near the water, and for 2 or 3 consecutive seasons were flooded out, and lost their eggs. After having shown no signs of increase for 3 years, they apparently decided to change their usual mode of procedure. Instead of building their nests out of reach of high floods, they still remained close to the water's edge, but got over the difficulty by erecting huge heaps of rushes and dry sticks, so constructed that when the floods came they floated on the surface of the water. Consequently, the female birds could remain sitting on the eggs in spite of a general rise in the level of the lagoon, and on the flood subsiding they were again safely stranded on dry land. Since this method was adopted, it has become the general practice for black swans on the west coast to construct floating nests, and they now never lose their eggs in floods. Whether the swans in other parts of the colony follow this rule or not, I do not know, but it certainly took them 3 years to discover this mode of avoiding floods on the west coast. I was told of it by a man who is a keen naturalist, and who observed the whole proceeding from their first appearance to their adoption of the new plan. Note 4. Mount Egmont. In company with Mr. C. Wiggins and my brother, R.T. Harper, I made the ascent of Mount Egmont in December 1895, and was interested to find so much similarity between the vegetation on the peak and that on the Southern Alps. Egmont, Taranaki as the Maoris call it, is an extinct volcano of 8,260 feet in the North Island, and rises from a practically level plain of 200 feet above sea level. It is the most perfect cone that it is possible to conceive. Egmont has been said by persons who have seen both to rival Fusiyama of Japan. From a mountaineering point of view, it is only a very steep walk, no hand and foot climbing being necessary, and there are in the summer well-beaten tracks to the summit. When we went up, it was coated with snow from 6,300 feet to the top, and consequently we had a much less tedious walk than it would have been when the loose scoria is uncovered. However, curiously enough, an ascent with much snow on the peak is rarely, if ever, made. Nearly all expeditions are postponed till the peak has put off his winter garb. In spite of the height above sea level, there was no sign of glacier ice, and though in accounts of climbs which are constantly appearing, we see the mention of glaciers, notably the "Chadwick Glacier," it is erroneous to suppose that glacier ice exists. There are several hard snow patches all through the summer, but no more. When snow is on the peak, there is necessarily a certain amount of ice or frozen snow, in which a step or two have to be cut, and this has given rise probably to the idea concerning glaciers. The interesting feature to me in the climb was that from 4,000 feet, a low, dense alpine scrub was found, extending up to about 5,000 feet above sea level. This grew to 15 feet in height at the lower limit, and gradually became dwarfed to 2 feet at the upper level. In nearly every respect it is the same as that on the southern Alps. With the exception of the Nainai, I saw all the other chief shrubs. Above this, the grass and alpine flowers were found, very poor in variety and size. However, the few varieties seen were also to be found on the southern Alps. The transplanting of the ranunculus lyalii, Celmisias, and edelweiss would no doubt be simple and meet with success. The reason why I was surprised at the presence of this vegetation is that Egmont is isolated. The nearest mountain which attains an altitude sufficiently high to carry subalpine vegetation is Ruapehu, 9,167 feet, and it is 80 miles away as the crow flies, and with Mount Tongariro and Narahoe, is probably the only peak besides Egmont on which such vegetation could be found in the North Island. In any case, it is the nearest mountain to Egmont of sufficient altitude. Narahoe, 7,376 feet, is still an active volcano, but Tongariro, 6,500 feet, and Ruapehu are extinct. The latter has a hot crater lake surrounded by perpetual ice, which by its melting feeds the lake. Accounts of this peak are to be found in the Proceedings of the Royal Geographical Society, 1885, page 272, also New Zealand Lands and Survey Reports of the years 1893-4 and 1894-5. Note 5. Fitzgerald's Pass and C.E. Douglas. It is a remarkable instance of the truth of the old proverb, "A prophet is not without honour save in his own country," that when Mr. Fitzgerald and Zurbriggen went over the range from the Hermitage to the west coast, the Christchurch and other newspapers wrote articles on the "Discovery," stating that it was a notable fact that Mr. Douglas had been for some years looking for a pass to the Hermitage and had been unsuccessful, though he had actually been up this very river, the Copeland, and that Mr. Fitzgerald, who had only been in the colony for a few weeks, had been able to do that which had beaten the government explorer. The latter stated in the Alpine Journal of August, 1895, that parties had tried to find a pass, but had been unsuccessful, and therefore he himself decided to undertake the task. Both these observations are most unjust, because the instructions Douglas had were to find some saddle, "free of snow and ice for 3 months every year," in order to allow a track to be taken to the Hermitage from the west coast. There had been numbers of passes made since 1857 from coast to coast, but they were either not in the Hermitage district or did not fulfil this condition. Fitzgerald's Pass itself does not fulfil the requirements of the government, and should never have been noticed as valuable in that respect, though it is so in others. No doubt a track could be taken over it, and it will have to be accepted as the best and only route in the course of time. Douglas stated in his report, which he made with a map in 1892, a map used by both Fitzgerald and myself in our journeys down the Copeland, that he found a high saddle fairly free of snow. But as it would not be free for the period required by government, he did not ascend or cross it. The observation therefore was made recklessly, and without any inquiry into the real instructions or requirements of the government. To anyone who knows Douglas and his work in the past, the idea that he could not force a way over a pass of this kind is absurd, for no one has done such good work as he has in the New Zealand Alps. To give more than a bare record of his explorations would be impossible, for he began traversing and exploring the rivers of South Westland in 1874, and continued with few interruptions until November 1895, when he had to leave me in the Karangarua River. The full records of his work are in the Survey Office at Hokitika, and as space will not allow me to enter into details, it will be sufficient to enumerate shortly the actual rivers explored by him, taking them in their order of position, not of date. In 1884, Douglas explored the Arawata River, at the head of which is the Grand Alpine district of the Aspiring Group, several fine summits rising between 8,000 and 10,000 feet above sea level. From an alpine point of view they are untouched, for Douglas did not go above the snow line, except in the case of the Bonar, a fine disconnected glacier, similar though far smaller than the Douglas up the Twain River. The Waipara River drains the ice field and flows into the Arawata. The Waiatoto River, coming from the ranges near Castor and Pollux, two fine peaks of nearly 9,000 feet, he has traversed to its head. It drains the Therma and Pickelhaub glaciers, the former of which he went up. He describes it as being walled in, like the Balfour, by wonderful terraces and cliffs of rock, rising sheer for 2,000 feet, one of the most striking scenes he has witnessed. The ice lines are in this valley most marked, and the rocks polished and grooved in a very noticeable manner. In fact, Douglas constantly refers to the head of these two rivers as containing some of the grandest and most magnificent scenery he knows, and it is not very difficult to reach. If it exceeds in grandeur the country he and I have seen together, I can only say it must be very wonderful. He twice reached the summit of the dividing range here, low saddles to Otago being the rule. The Okura River is another draining the divide, and was explored by Douglas. It has a low pass at the head, which he crossed, the Actor Pass, and which is accessible for a horse on the eastern side. The Landsborough River, the longest on the west coast, was first explored and traversed by a party led by Douglas. Particulars of this river can be seen in the previous chapter. Going further north, we come to the Paringa River, with its tributary the Otoko, and the Copeland River, which, with the Turnbull, Cascade, and Maitahi rivers, were all explored, mapped, and reported on by him. The Turnbull and Cascade should have been mentioned earlier, as they lie away south. His work in conjunction with me has already been chronicled, and had the above explorations been recorded as fully, we should have at least 3 volumes of the same size as this. His reports are voluminous and most interesting. He has a quaint, amusing style of describing the natural features of the country, which are, however, most faithfully recorded, and the theories advanced are valuable. Unfortunately, I cannot persuade him to write an account of his work. It is no use to tell him he ought not to keep such interesting matter to himself. Had I time to look over his diaries and reports, I could, with help, produce a very thorough and valuable record of this southern country, but I am not a man of leisure, and the diaries are in the safe of a government department. As a naturalist and explorer, Douglas has had few equals in New Zealand. No amount of hardship or difficulty deterred him from his purpose. He was painstaking and accurate in his reports. He has explored chiefly from love of such work, and only recently received aid from the government. He never exaggerated his difficulties or the results of the expedition. He never attempted to take credit for a single thing which he had not done. He always allowed his companion, when he had one, a full share in the honour of the exploration, and never tried to add to his own credit by deprecating the work of others. In fact, he is, in my opinion, an ideal explorer. A vast deal of his travelling was done alone, with only a dog for company. He carried little until the gradual disappearance of birds compelled him to increase his loads. Douglas says he does not believe in a man unless he has a petty vice, and that is the reason, I suppose, why he allows the virtue of modesty to become almost a vice. These notes concerning him are written without his knowledge, for I feared to risk a refusal if I asked his leave. I have taken the responsibility because I feel that a man who has done what he has in the past, and who is too worn out to do much more, ought not to be allowed to hide his light under a bushel. It is of public interest, to New Zealanders at any rate, that he should be known as a great explorer. Many who have done work of 100 times less importance are well known in the colony, and some who have done far less in other parts of the world, with all the advantages of porters, guides, and other luxuries, are of worldwide renown, while for the want of a few words Douglas remains unknown, save to a small circle, even in New Zealand. Had he written or lectured on his work, he would have ere now received honours from learned societies as a naturalist and explorer. I trust he will forgive me for dragging him before the public from his remote corner of Westland, and hope he will look upon my action in so doing as evidence of the great admiration I have for his past work. Note 6. Early Explorations. The names of those whose work has materially advanced our knowledge of the topographical features of the central portion of the Southern Alps should be recorded. On the east coast in 1862, Sir Julius von Haast made the first recorded exploration into the Tasman district. In 1867 and 1870, Mr. E. P. Seeley photographed and explored the Tasman, Hooker, and Müller to their upper basins, also the Godley and Classen glaciers at the head of the Tekapo River. In 1882, the Rev. W. S. Green practically ascended Mount Cook, and his climb should be considered the first real ascent. Beyond information respecting the eastern slopes of that peak, his climb was not of topographical importance. In 1883, Dr. von Lindenfeld made a survey, with some rather bad errors owing to a faulty theodolite of the Tasman Glacier. In 1889, 90, 91, Mr. T. N. Broderick completed the survey of the eastern glaciers, including the Godley and Classen on the Tekapo River. In 1890, Messrs. G. E. Mannering, M. Hamilton, and I made the first exploration of the Murchison Glacier and Valley, as already related. In the same year, Messrs. G. E. Mannering and M. Dixon on Mount Cook, and R. Blackiston and I on Harper's Saddle, confirmed the fact that Mount Cook did not lie on the Dividing Range. On the west coast in the 70s, the geodesical surveyor carried a triangulation down the coast, fixing all the high peaks. And between 1892 and 1895, Douglas and I explored, as related in the foregoing pages, all the valleys and glaciers of Westland in this district. Thus, with the one exception of the Tasman Glacier, the exploration of this district, both east and west, has been carried out by the enterprise of New Zealanders. It remains to be seen when and by whom the Alpine exploration of other districts, named in Chapter 1, will be completed. Let us hope that New Zealanders will not allow the credit of that work to be taken from them by visitors from other countries, and that they will hold their own in the matter of climbing peaks as well. Note 7. Measurement cairns and photographs for reference. While on the Franz Josef, I placed some cairns on the eastern bank of the glacier, and for sake of reference, while there, distinguished them with letters of the alphabet, with the letter M prefixed to avoid confusion with other survey stations. These are in brackets in the following table, and the cairns are numbered from the terminal face upwards. Cairn 1, MF. Distance from nearest ice, 39 feet. Height above the edge of glacier, 25 feet. Date, 19th September 1894. Cairn 2, ME. Distance from nearest ice, 48 feet. Height above the edge of glacier, 20 feet. Date, September 19th, 1894. Cairn 3, MD. Distance from nearest ice. Photograph cairn. Height above the edge of glacier. See below. Date, September 19th, 1894. Cairn 4, M. Distance from nearest ice. 198 feet. Height above the edge of glacier, 70 feet. Date, September 16th, 1894. Cairn 5, MA. Distance from nearest ice, 23 feet. Height above edge of glacier, 15 feet. Date, September 16th, 1894. Cairn 6, MB. Distance from nearest ice, 111 feet. Height above the edge of glacier, 40 feet. Date, September 16th, 1894. Cairn 7, MC. Distance from nearest ice, 30 feet. Height above the edge of glacier, 20 feet. Date, September 16th, 1894. The first two are on the south and north banks of Arch and Rope Creeks, respectively. Number 3 is on the north bank of a small creek reached after passing Rope Creek. Number 4 is some 18 chains south of number 2, on the line of stones forming a remnant of lateral moraine. Number 5 is on the south bank of a deep gorge, about 30 chains south of Rope Creek, on a large hummock of rock. Number 6 is about 4 chains south, and 50 feet below a large erratic block on the lateral line of stones, just before reaching the rocky cape, E on the map. And number 7 is on a knob of rock, south of the last small creek, immediately below the said point E. In December 1893, number 4 was the only cairn erected, and was 209 feet away from the ice, according to a note I have from Douglas. There is some error in this figure, because the ice had not noticeably retreated, and not advanced, in September 1894. For future visitors, I may mention that Arch Creek is the deep gorge at the mouth of which an isolated roche moutonneee stands, and Rope Creek is a large stream flowing in a shallower gorge, some 20 chains south of the former. The edge of the glacier mentioned in the third column is the point at which the ice meets the rock. The cairns are heaps of stones of 2 and 3 feet high, on the bare ice-worn bank, and easily seen. The only other mark we have is a plus on the back of the Sentinel Rock, about 4 feet from the ground and 2 chains from the western end, but I fear it will not be easily found except by us, for it has weathered a great deal. The paint, which should have been sent to the Franz Josef, went on to Gillespie's, and we were unable to use it. This plus I have already mentioned in Chapter 11, also the general retreat visible on my second visit. Photographs from the Sentinel Rock, looking east. From the Barren Rock, showing the contact of ice and rock at the outlet on the eastern bank. From the point at which the horse track descends onto the gravel flat, showing the whole terminal face. From cairn number 3, in the above table, looking south, to show the encroachment of the ice on the rock bank. And from cairn 6, looking towards point E, can be compared with similar photographs taken by me and in possession of the Alpine Club Glacier Committee. Unfortunately, a dozen or more taken in September 1894, especially for the purpose of comparison, were lost when my load went out to sea on the way to Gillespie's. On the Fox Glacier, owing to mishaps and general bad luck, we only built 2 cairns. One of these is on a small terminal moraine, between the fringe of scrub and the ice, right at the terminal face. This was on April 4th, 1894, distant 43 yards from the ice, in a direction of 96 degrees 30 minutes, magnetic, and lines drawn at 150 degrees 30 minutes to the south, and 25 degrees 30 minutes to the north, touch the furthest advance of ice on each side. On the north side of the terminal face, the ice touches the rocky hillside, until within 8 chains of the actual terminal, and then it leaves the rock and continues to the snout at a distance of 10 to 30 yards from the hillside. On the southern side we erected a cairn on a ledge at the foot of the Cone Rock, which ought easily to be found. On April 25th, 1894, at a bearing of 355 magnetic, the ice was 37 yards distant. Photographs should be taken from a stone in the large creek, which joins the river here, about 1 chain from its inflow into the river, looking north to show the terminal, and east to show the encroachment of the ice on the side of the Cone Rock. Photographs also showing the position of the ice on the various rocky capes on the north side of the valley can be compared with those I have taken. The only other Westland Glacier which has any special interest for future observation is the Douglas. I think a series of photographs of the neve would be valuable to show whether it is gaining, losing, or stationary. A picture taken from Douglas Pass, or the lateral moraine just below the northern end of the gravel flat, would show any alteration if compared with those I have taken. Unfortunately, I had too much to do when in the Twain Valley to spend time over erecting cairns, for the work done there occupied about 12 hours each day, and as I was working alone it was quite enough to do without even an additional hour or 2 to fix cairns. It would, however, be a most interesting thing to compare the rate of increase or decrease of the trunk with that of the neve, for there must be some law of relation between the bulk of the supply and the glacier ice, and this may help, a little at least, towards its discovery. These marks, and suggestions as to photographs, have here been recorded in hopes that someone, in the future, may make fresh measurements for comparisons. The 2 first-named glaciers may expect many visitors, for they are easily reached, but the Douglas is too remote to have much attention paid it for many years. The Franz Josef, however, is the most likely of the 3 to attract visitors, for it has a horse track to its terminal. I therefore made a point of placing the various cairns along its side. In the interests of glacier science, it is to be hoped that some visitor will check the position of the ice and send the results, with photographs, to the Alpine Club, London. Everyone should remember that any measurement or photograph, however insignificant, is of value, which shows the position of the ice with regard to some conspicuous object. We may not realise the value of such ourselves, but those investigating the laws of glacier motion and action in the Alpine Club Committee can put forward theories if we send them facts. Surely it is worthwhile to devote a day to such useful work, instead of spending the whole time in scaling peaks and bringing back no information of value. End of the Appendix. Read by Gail Timmerman Vaughan. End of Pioneer Work in the Alps of New Zealand, a record of the first exploration of the chief glaciers and ranges of the Southern Alps, by Arthur Paul Harper.